Hi, everyone. Our project is called LockdIn. Next slide, please. As we use online learning more and more, we wanted to give professors a way to get some active feedback on how students are perceiving their lectures. We planned on doing so by taking still frames of Zoom lectures, passing them through a neural network model, and then getting an engagement classification. We're accepting the limitations that we're assuming most people are going to have their cameras turned on, and that if someone's engaged, they're engaged on the Zoom meeting itself. Next slide, please.
So with regards to data collection, we started by looking at databases of facial expressions online. And then once we did more research, as suggested, regarding more indicators of engagement versus unengagement, we opted to label and collect the data ourselves. We made various combinations of indicators that were outlined in research papers and used those as a reference with our participants. Next slide, please. So we recruited several students to get on Zoom calls and pose with their interpretations of these indicators to make the data feel as natural as possible. And then they were labeled in accordance with our research, with the research papers that we found. And then our goal was to basically make the process of labeling as objective as possible based on the indicators that were outlined for us. We also found that the aspect ratio of the actual image cells in a Zoom call doesn't change regardless of how many participants you have, as long as it's more than two. So we were able to develop a script to extract those actual image cells and pass them on to our augmentation process. Next slide, please.
Right, so for our data augmentation, we took the labeled data from our collection process and experimented with different variations of augmentations, ultimately settling on utilizing blur, brightness adjustments, as well as a horizontal flip. We found that this combination of augmentations to produce 5 images for every collected image gave us the most data to work with without impacting the overall training of our model. Next slide, please.
So for our baseline model, we chose a simple linear model just with one hidden layer. Next slide, please. And then for our final model, next slide. For a final model, it was a 2-layer CNN with one hidden output layer. And we chose CNN because we believed that it was good for still image processing and it could capture some of the features that we wanted to see in engagement. Next slide, please.
So here you can see the graphs for our losses and accuracies with respect to the CNN and the best MLP model. So we see that the linear model produces some competitive results if you're looking at, let's say, just a validation accuracy or just a test accuracy. But we needed these other metrics to notice that the MLP is consistently overfitting our data very early on in all the experimental runs that we did, regardless of how we change parameters or the structure of the actual model itself. And in the end, our hypothesis of using a CNN as the more superior model was proven to be true because it was becoming obvious that the MLP was effectively memorizing our data set. Next slide, please.
Right, so in terms of our qualitative results, we can see that some of the incorrectly classified images were not sort of concretely engaged versus unengaged or the other way around, which may have been an issue during data processing as seen by some of the figures shown here. Next slide, please. In addition, we also chose to extract a feature map from our final model to show essentially what features our model was using to classify engagement. So from several feature maps and from the figures shown, we saw that our model was definitely taking a lot of emphasis on the orientation of the shoulders and the head, which is something that we originally attributed to engagement. However, one thing that we did notice was that we also predicted that gaze would play a big part in the classification. However, as seen on only some of the feature maps, it did not have nearly as the same emphasis on it as the orientation of the shoulders and head did. So this could be a big reason for some of our incorrect classifications, as a big portion of our labeling had to do with eye gaze as an indicator for engagement. Next slide, please.
Right. So now for the actual demo part, Christian. So once Christian is on, Christian will show you a 10-second clip of myself in a traditional engaged pose and a little bit of an unengaged pose to start. From here, we'll extract some frames periodically and pass them through our classifier and give you an overall average engagement over these 10 seconds.
I just want to make sure you guys can see the
Yeah.
Yeah, okay. So here's us. This script extracts our frames, and then this script is going to pass them through our model. And as you can see, we get like an overall engagement about 63%, which is what we were expecting, something more on the engaged side. And if we look at like individual frames that we've captured, here we see Sasquatch's clearly disengaged, and we get an reading as so. Here we get a incorrect reading. However, it is leaning towards the disengaged side. We believe it's incorrect because this one's probably incorrect because it's not picking up on the eyes, and then we see some of the correct engagements here where Shas is clearly engaged. And then I'll leave it off to Jeffrey to finish off here.
Right. So finally, we believe that we were able to train a model that encompassed many different expressions of engagement and is applicable over a wide set of environments. And this is in part due to, I guess, the diversity of our collected data in both the expressions as well as the participants. And we recognize that while the accuracy is not perfect, the data can still be used effectively in a variety of settings. So the application of this project can produce an
Great,
app.
that's that.
Okay.
I think you had everything. There was nothing left on your slides, so that's interesting. It's an interesting attempt to do something. It's a tough thing to do because it's a very subjective metric, and that's where I want to start with my questions. You talked about, used the word indicators. Where was that indicator thing? No, you talked about it somewhere up here.
I mean, like, I mostly just said it, yes, but
yeah. So the question is, give me an example of 3 indicators that's in your
right, for example. Okay, right. So one very common example is the actual gaze direction. So like the way your head is being tilted, if the model is able to recognize all your features as a normal face should be, it would say that it's that you're looking.
Slow down. So gaze direction, that means which way you're looking.
Yes. So gaze direction / head tilt sort of fell into the same category from the papers that we read. And it basically said that to like simplify our model, we like assumed that the camera was
you got to answer let's try to answer the question and stick to the question. Let's just talk, okay? Gaze direction is where your eyes are looking, and it is sometimes indicated by not the tilt of your head, it's the angle of your head, actually.
Right.
So gaze direction's 1. Give me 2 more, but don't go into long explanations. Just tell me.
Okay. Another one is the portion of your face that's being covered by your hand, which usually is indicative of boredom.
Next one.
Right. And then another one would be the eyes specifically, whether they're like sort of focused in one spot, or whether your eyelids are like drooping or like almost closed, or basically an indicator of how tired you look based on the eye specifically.
Like eye visibility. So
yes.
Second one, what was the second one? Was called? I was trying to write that down. What was the second one? Say it again.
The second one was the portion of your face that's being covered by your hand.
Yeah, covered face. Okay. Okay, it would have been nice to see those kind of described to get some sense. And I realized, this presentation, there's 2 things. You had all kinds of animations in it. So if for anyone else, just say next if you know there's an animation.
Yes. Sorry about that. Because when we were practicing, practicing off a PDF version that didn't have the animation.
This is a PDF version. Thirdly, the other thing is this thing in particular would have benefited from you being able to point at what you're talking about here. So you said all kinds of things. I didn't know which one to look at. Can you just pick one? Tell me what one to pick and tell me what it does. So give me a column 1, 2, 3, 4, and number down 1, 2, 3, 4, 5.
So for example, one of the more vivid ones is, let's say, the 3rd column, 5th row. So that you can very clearly see the outline of the overall like orientation of the head and shoulders, as well as a bit of focus on the eyes, which is kind of something that what we were talking about earlier.
Okay, so this is a picture of a kernel, and brighter means matters more. Is that right?
Yeah.
And so.
So these are essentially the features that we picked out.
Okay. Interesting. One quick note: you referred to your baseline is a linear model. It's not. It's got a non-linearity in it. So just don't want people exiting the course saying wrong things like that. That would not be good in an interview. You get that, right? This is
Right.
yeah. Okay. Yeah. I've called it an MLP. One problem, by the way, this is a little bit my fault. Some people, I've been referring to fully connected networks as multi-layer perceptrons. Not everybody kind of does it that way. So, but
Okay.
not very consistent.
Just to point back to the actual like indicators, so like sorry we didn't include a graphic for that in here, but there is a chart for that in our final report for reference.
That's great. Imtihan, do you have anything on this?
Yeah. So my first question was the same. What were your engagement indicators? How did you measure those indicators to figure out the labels for your images?
That's a good question. That's a good question. I meant to ask that too.
Zenny, do you wanna take this one?
How we measured them, sorry?
Yeah, so you mentioned a few indicators, right? But your final labels are binary labels. So
Right.
how did you combine those labels to form your binary labels?
Combine the indicators to form the binary label.
Sorry, yes. Yeah, your indicators.
Yeah, so for example, if we found that there was a large majority of the indicators were like disengaged, then we would just say it was disengaged. If a large majority of them were engaged, then it'd be engaged. So giving what Shah said, if they're looking, like gazing straight ahead, and then their eyes are a little closed, and their hands.
Sorry, that's a little bit too detailed. So the real question is, well, who did the labeling? Was it one person or many people?
No, it was like all of us going through several data because we had a lot of just raw data to like manually label.
Okay, so all of you looked at all of them. All of you looked at some of them. Subset.
We all looked at almost all of them. Like I think there were very few data points that were not looked at by all three of us. So the level of objectiveness is not severe, or sorry, is severe, and the level of subjectiveness was not an issue in our opinion.
So you had three labels to compare, I guess, and so did you do some voting among the three labelers, or did you take the majority, or how did you do it?
Based on like we just discussed the ones that were like seemed to be an issue, and then we just sort of referenced the research papers and just gave it our best shot.
So you came to consensus.
Yeah.
I'm trying to get. Sorry, I'm interrupting, but there are simple ways to say these answers. Okay, that's interesting.
That doesn't completely answer the question I was having, though. So your engagement indicators, how did you use them when labeling? So you said that like gaze is one thing. So, and then what was one of the other ones?
Hand on face.
Yeah, so hand on face gaze. Did you label it as engaged if, let's say, two of the indicators were saying engaged, or were you just qualitatively looking at it and saying, okay, this looks generally engaging?
I think we kind of mixed both. Like occasionally we would tell people, hey, can you do this? And then that would end up being more like disengaged when we looked at it than it was engaged. But for the most part, we tried to stick to our indicators. And if there were more indicators that were engaged, we would label it engaged. But occasionally you would have like a mix up.
That makes sense. And my second question was, if your baseline model, which has fewer parameters, overfits, how did you address this in your final model? Like, because your final model has way more parameters. So if your baseline model overfits, how come your final model didn't? Or like, do you have a justification for it?
I would say I'm not too sure.
Honestly, based on the detail of the problem, we didn't really know how to justify that. We just knew that the MLP model was actually like overfitting based on the output it gave, and the CNN sort of gave more consistent results overall when we tested it on like test cases that were test cases that we tested, for example, for stuff like the demo. So like we don't really know why it happened, but we just sort of trusted that the CNN was just better because
Is there something here that shows it's overfitting? What is it that you point out that shows the linear model overfitting? Is it
Very low training losses.
this?
yeah. So basically, so like in both graphs, the red is the training, and then the blue is the validation.
So that's the evidence for overfitting. Yeah, I actually lost the thread when you're saying accuracy doesn't really tell you what you need to know.
What I said was, if you look at just accuracy, it's not going to tell you what you need to know, and it's not going to make it obvious that the MLP being close to the CNN in results means that it's just as good. But when you look at the actual graphs of the losses, it shows that the MLP is actually, I guess, seen to be memorizing, where the CNN has closer validation and training results.
The test is something that can't be memorized. So accuracy on the test set is supposed to be legitimate. So that's the thing that tells the tale. This is not the thing that tells the tale. This is just giving you hints. But this is the truth, right? So your explanation is, well, it looks like it's overfitting from this graph, but your test set is not saying that. No matter how many words you kind of say. So you have to be careful using too many words. You're going to convince yourself of something. We're going to have to move on. I'll give a moment to anyone else in the class, comments, questions, suggestions. All right, thanks. Interesting and difficult thing to try to do. I enjoyed thinking about this.